So the 5-3 homework is over those polynomials. The homework are the odds only from 7 to 57. Let's do one from each section. Let's look at the instructions here for problems 6 through 23. It says for the following exercises, find the x or t intercepts. The reason they use x or t, those are the two variables you see in the equations of the following polynomials. Now, it doesn't matter whether you call it an x or a t, it's the same procedure. If we look at one like number 7, it is already in factored form. Just set that equal to 0, solve for each individual factor. What I would like to do is one that is not factored, so let's do number 17. So our goal here is to get it into factored form so we can easily set it equal to 0. If I notice here, there are 4 terms. There are no greatest common factors, nothing that they have in common. But our powers are going 3, 2, 1. I see 2, which is half or double of 1, and 8, which is double of 4. So there's some patterns there. So that's a good indication that we're going to use something called grouping. Okay. Now, for grouping, group the first 2 together and the second 2 together. We're going to we are going to factor out the greatest common factor 2 at a time. The greatest common factor for the first 2, they both contain an x. The lowest power is an x squared. If I take out an x squared, I am left with 2x minus 1. Now we have to have that 1 there so that if we were to distribute, it would work out. Now, you'll notice that in this parenthesis is our kind of, our anchor of what we're looking for. The 2x is positive and the 1 is negative. You'll notice that the signs here have switched. The first one's negative, but the last one's positive. That's an indication that we want to take out a negative from there. Both 8 and 4 are divisible by 4, so we're going to take out a negative 4. When we take out a negative, the 8x becomes a positive 2x, and the positive 4 becomes a negative 1. Now, we know we've done it right if these two quantities match. That's the way you know you're on the right track for grouping. Now, what that means is that we can take out a 2x minus 1, and we're left with an x squared minus 4. Now, when that's the case, we want to make sure that all the pieces are factored as far as we possibly can. Well, x squared minus 4 is a factorable quantity. So that factors to be 2x minus 1. X squared minus 4, that's the difference of squares. We can use the square roots to help us. That's going to be x plus 2 and x minus 2. Now, once we have it in factored form, we are not done. Take your factored form. Set it equal to 0. That's how we find the x-intercepts. And then we are going to break it apart. Each individual factor gets a 0. So we get 2x minus 1 equals 0, x plus 2 equals 0, or x minus 2 could equal 0. The zero product property tells us that any one of those could be the thing that caused the 0. So each one of those gets its own 0. We can pull it apart. Now the first one, we have to add 1 to both sides and then divide by 2. So you'll notice that 2 that was stuck on the x becomes a denominator, fractional answer. Here is negative 2. Here is positive 2. For the most part, for many of these, if your highest power is 3, and you should usually get 3 zeros if the highest power is 3, 4 zeros if the highest power is 4. These, I think, all end up being either real zeros. Some are all unique and some have repeats, but Let's go ahead and look at problem 23 now. Let's do the same thing. First thing you want to do is look at, is it a factorable quantity? Well, they're all divisible by x. So we can remove an x from all pieces. So the x's go down by a power of 1. Now, when this is a 4 and this is a 2 and then it goes away, that's a good indication. They have set it up so that it's factorable into 2 pieces. So we have to ask ourselves, what is the power, what factors of 4 add up to the 5 in the middle? Well, 4 and 1 are the things we want. So this would be x squared minus 4 and x squared minus 1. Both of those are a difference of squares. Factor them one more time. Don't forget that x in the front. So we get x plus 2, x minus 2 for the x squared minus 4. We get x plus 1, x minus 1 for the x squared minus 1. So like I mentioned earlier, we have a power of 5. We have 5 things there. That's a good indication that we did it right. And now remember, we're going to set that equal to 0. Which allows us to pull it apart into 5 individual equations. So x equals 0 is kind of just done. X plus 2 equals 0 gives us a 0 of negative 2. X minus 2 gives us an x-intercept of positive 2. X plus 1 gives us an x-intercept of negative 1. And x minus 1 gives us a 0 of positive 2. So we have 5 zeros, 0, negative 2, positive 2, negative 1, positive 1. So that's what you want to do for this initial section here, please. If it's in factored form, each factor gets set equal to 0. You're going to solve them individually. If it's not in factored form, you got to factor it, then set each piece equal to 0 to find those x-intercepts.
Put that on there for
Okay. Okay, now I would like to look at this section. It says, for the following exercises, use the intermediate value theorem to confirm that the given polynomial has at least one 0 within the given interval. So let's do 25 together. And go ahead and skip 29. So I just want you to do 27. We'll do 25 together. So we've got our function f of x is x cubed minus 9x. We're checking to see if there's a 0 between 2 and 4. So what we're going to do first off is start out plugging in all of the whole numbers between 2 and 4, all of the integers between 2 and 4. Now, if we do not get a switch there, we don't see a positive-negative switch, then we'll go to the halves. We don't see a switch, then we can go to the tenths. We can keep breaking those intervals down smaller and smaller. But hopefully we'll find one in that interval using the whole numbers. If we plug in 2, we get 8 minus 18, which is negative 10. If we plug in 3, we get 27 minus 27, which is 0. We really can stop. We found one. All it says is, can you find a 0 between there? So always check the integers first. If you don't get a 0, but if you get one was positive and one was negative, there's a 0 right in the middle of those two values. Okay, so for 27, you want to check first 1, 2, and 3. You're looking for either a switch in signs from positive to negative or an actual 0. If you don't find that switch initially, you can plug in 1.5 and 2.5 to see if you can find a switch somewhere in there. But they said there's at least one in there, so you should be able to find it. Okay. Now let's talk about 31 to 41. It says, for the following exercises, find the zeros and give their multiplicity. So 31 is the ideal. It is in factored form. So let's do one that's factored and one that is not. Okay. So the zeros, remember, are just the x-intercepts. So it's technically the same thing from the top as far as identifying the zeros. So this is in factored form. So the zeros are x squared, 2x plus 3, and x minus 4 are the factors that are going to give us the zeros. Now the first one has a multiplicity of 2, which we can ignore for now and just solve it. And we would just say the multiplicity is 2. Just put times 2. The next one, we're just going to solve 2x plus 3 equals 0. Ignore the 5 for now. We'll list that as a multiplicity. That's 2x equals negative 3. X equals negative 3 halves. That has a multiplicity of 5. And then x minus 4 equals 0 at 4, which has a multiplicity of 2. Now that's all they want us to do. And if it's in factored form, yay, that's great. But the problem is some of them are not in factored form. So what I would like to do is I would like to do 37 together. And I think that will kind of push us in the correct direction how to do these. So when finding x-intercepts or zeros, whatever you call them, you want it in factored form. And so what I notice about 37 is that they are all divisible by x. The lowest power is an x to the 4th. So I can remove an x to the 4th from every piece, leaving me with an x squared minus x minus 2. Now, our goal is if x squared minus x minus 2 is factorable, to factor it. If it's not factorable, the zeros can be found by using the quadratic formula. But it is a factorable quantity. That is x minus 2 times x plus 1. Now, why is that? Well, negative 2 times 1 is the negative 2 we see here. Negative 2 plus 1 is the negative 1 we see there. So now it's in factored form. So now we can find the zeros or the x-intercepts, and we can mention any multiplicities. The x to the 4th equals 0 gives us an x-intercept of 0 with a multiplicity of that power of 4. Now, x minus 2 equals 0 at 2. It has no multiplicity. You can say the multiplicity is 1 if you want. Remember, the odd ones, like x minus 2, on the graph will go through the graph. It won't bounce off of it, but the x to the 4th will make it bounce off of the x-axis at 0. And then finally, our x plus 1 equals 0 gives us a 0 at negative 1. So if you were to graph this at x squared and at negative 1, at x equals 2 and x equals negative 1, we will strike through, we will go through the x-axis in that spot. But at an x value of 0, we will bounce off the x-axis. If we're coming up from the bottom, it's like we're bouncing off the ceiling. If we're coming from the top, it's like we're bouncing off the floor. So that's kind of what you need to do for that section there, problems 31 to 41. Now let's take a look at our next section, 42 to 47. Let's read what it says. For the following exercises, graph the polynomials, note the x and y-intercepts, multiplicity, and the end behavior. I would like to do 43 with you now, and then 45 and 47 are on their own. So let me get some graph paper. Okay, so let's take a look. So we're going to do 43. So the technique I'm going to show you is kind of where you want to start every single time when they ask you to graph it. So the first thing I want you to do, if it is in factored form, find the zeros or the x-intercepts. So we're going to set each factor equal to 0. And we're going to note any multiplicities that are not 1. So this one has a multiplicity of 2. Next, I want you to find the y-intercept. So we're just going to plug in 0. If we plug in 0, we get 4 times -1 squared. Now we'll note the powers. So that -1, when we square it, becomes a positive. So it becomes 4 times 1, which is 4. So that's the 0.04. Okay, so we found those. Now what did they say again? Let's read. So they wanted x-intercepts, y-intercepts, multiplicity. The next thing I want to talk about is the end behavior. If there is any front coefficient or front x, you have to include it. There isn't one, or there's a 1 there. Let's break down our lead term, which will help us do the end behavior, which will help us graph it. So our lead term is going to be the x from the first quantity, and an x squared from the second quantity, or an x cubed. And then just draw a little graph picture to show me the end behavior. That's all I need right now. And then let's put it all together and let's graph it. So at -4, we have a 0. At +1, we have a 0. We hit the y-axis at 4. Go to the leftmost 0 and make a section that's going downward. And go to the rightmost 0 and find a section that's going up. Now here's where the multiplicities, the bounces or strike-throughs, is going to go through. At -4, we have a go through the point. So let's go through the point and just head to here. Now, that might not be exactly where the hill is, but remember, until you get to a calculus class, the hills are going to be kind of ambiguous. So if you want to plug in a point like -1 or -2 to find how high that goes, fine. It doesn't matter to me. So you could have even drawn it like this. Well, like this. Okay, I don't care. But this piece here, we have to bounce off the x-axis. So our graph should look something like that. Again, how high this bump goes, if you want to be precise, plug in -1, -2, or -3. You'll get a little better picture of how high it goes. So that's how you would graph a one like 43. That's the 42 to 47 section. Okay, that's that. Next, let's talk about problems 49 through 55. It says, for the following exercises, use the graphs to write a formula for the function. What I would like to do is I would like to do 49 with you. Now this is like our last example from the notes. So we're going to set up all of the zeros, and we're going to set up finding that A. Okay. So what do we know about number 49? Well, we know it has a 0 at negative 3. That's a factor of x plus 3. It went directly through it, so our power we're going to use is a 1. The next 0 as at negative 1. We went directly through it, so the power we're going to use on there is also a 1. The next 0 we come through is a 3. We went directly through it. There's no bounces, so we're just going to use one of those. And so what we know so far is that f of x equals a times x plus 3 times x plus 1 times x minus 3. So like if we look at number 50 here, at negative 1 on that graph, there's a bounce. So if I was doing this quantity on that graph, I would have to include 2 on the power. There's a bounce. So look at the difference. In 49 at negative 1, we went through it, so we only use a power of 1. If we were doing 50, there's a bounce at negative 1, so we would have to use a 2 there. The 2 is going to make a bounce. Now, last thing we're going to use to find our A value, which is positive 2, we're going to use that Y-intercept. That's the point 0, 2. So if I plug in 0 for all of the x's, I should get out a value of 2. And so 2 is the answer if I plug in a 0 where every x is sitting. So 2 equals a times negative 9. So a is 2 over negative 9, or negative 2 ninths. So we just have to write the equation one more time and we're done. So our equation final answer is negative 2 ninths times x plus 3 times x plus 1 times x minus 3. We should be able to put that into Desmos without a problem. And if we put it into Desmos without any issue, you should get a graph that looks pretty darn close to the one that you have in the notes. It will have the same x-intercepts and the same y-intercepts. The ends should go in the same direction. You'll notice our negative in front flips it, and if you look at our ends, they have been flipped. Left going up, right going down. So that is 49. The last problem is 55. Let me take a look at that one. Or I'm sorry, 57. If we take a look at 57, let's read the instructions. It says, for the following exercises, use the given information about the polynomial graph to write the equation. So this actually becomes pretty nice for 57. Let's do it together. The degree is 3. We have a 0 at negative 2. So we're going to start out, we're going to show that A. The negative 2 quantity gives me an x plus 2. Remember, it's always the opposite of the 0. The next one's going to give me the opposite of the 1, and the last one's going to give me the opposite of the 3. The only other piece of information they give us is the y-intercept is 0, negative 4. So if I plug in 0, I get negative 4. So the answer is -4 when I plug in 0. So it's actually easier in a way when they do it like 57 compared to the last ones where we had to pull that information from the graph. 2 times -1 times -3 is 6, so we get -4 equals 6a. So a equals -4/6. Any fraction, I want you to leave it in fractional form, just reduce it. They're both divisible by 2, so that's -2/3. So our final answer is f of x is -2/3, x plus 2, x minus 1, and x minus 3. Do we have a degree 3? Yes, we do, because this is a 1 and a 1 and a 1. All those x's together would make an x cubed for our lead term. So that is your homework for 5.3. I think that gives you a good start on it. So work on that. And if you get stuck on any, just ask, and I would be more than happy to help you.